Good morning, everyone, and welcome to this Green Business Fund technical webinar on refrigeration. My name's Sam. I'm a senior analyst here at the Carbon Trust, and I've been here for around 2 years, helping businesses of all sizes become more energy efficient. So we'll get started, and I'll go through the agenda for the session. So first thing that we'll go through is a brief introduction. So I'll look to introduce the Carbon Trust to those of you who may not know much about us, and then also the aims of this morning's session. And then, as you can see on the slide, we'll go through a number of different topics covering the basics of refrigeration right through to some case studies and some examples of energy saving opportunities that you might be able to take forward. So to begin with, the Carbon Trust has been around since 2001, and we are a not-for-profit organisation with a mission to accelerate the move to a sustainable low-carbon economy. So the services that we provide come from our independent experts, and we offer advice, footprinting services, and services on technology development. Today's webinar from the Green Business Fund sits firmly within the advice section of these offerings. And you can see some of the examples of some of the things that we, some of the schemes that we put forward from the Carbon Trust at the bottom of the screen there. For today's session, these are the aims. So we're going to look to try and improve your understanding on the basics of refrigeration systems. We're then going to move on to highlight the saving opportunities that are open to you as small and medium-sized businesses. Into making energy savings from your refrigeration system. And then we'll talk about the importance of regulation and how to future-proof yourself against kind of existing and future regulation that's coming in on refrigeration. And then finally, we'll talk about the Green Business Fund and the services that are available to you as businesses to help you become more energy efficient. So we'll start by talking about refrigeration in a kind of simplified, high-level view, so you have a better understanding and so therefore have a better chance of implementing energy saving. So the first thing to consider is the proportion of energy that's attributed to refrigeration across a number of sectors. So you can see here that there are a number of sectors that have a large proportion of their energy use being refrigeration. So where you can target these high levels of energy use, you can make considerable inroads into the savings, into your overall energy use. And that essentially means that you'll have more capital expenditure to use elsewhere in your business to invest or to improve your business in different ways. So just a brief example of where a lot of refrigeration energy is spent. So starting at the very beginning, what is refrigeration? So refrigeration is essentially the process by which heat is transferred from one location to another. So traditionally this is driven by mechanical work, and you can understand that the heat needs to be moved from one place to another. So for example, your cold room or freezer, the heat is moved from that space usually to an external source. So that's the very, very basics. In terms of the most common refrigeration system available to you, this will be the vapour compression cycle. So this is a simplified view of it, and we'll go through each step one by one. So the first stage of a standard refrigeration system is the evaporator. So this will start somewhere in your cold room, your fridge or your freezer, and it's where the low pressure liquid refrigerant will absorb heat and essentially evaporate into a gas. So efficiency gains can be found here when it's made easier for that liquid to collect that heat and be evaporated. So the thing to consider during this cycle is that pressure and temperature are proportional during this cycle. So the pressure is how the refrigerant is moved around the system and essentially how the heat is transferred. So moving on to the next stage of the cycle, this is the compressor. So this is where the superheated vapor that was once a liquid is now transferred, and is probably the most energy intensive part of the process. So being able to reduce the work that's done here is going to pay dividends in terms of your energy savings. It's where you can make probably the biggest savings in your refrigeration system. So in this part of the process, the pressure is increased, and it's this pressure increase that moves the heat, the refrigerant, to the condenser. So this is essentially the part of the system that removes the heat, usually to an external source. It's where you can consider the heat as being essentially dumped. So the latent heat is rejected by the system, and usually there's an ambient temperature which helps reduce the energy need here. So usually it's cooled by air or water in this part, but there are lots of different ways that the cooling can take place. Once the heat has been rejected, the refrigerant becomes once more a liquid, passes through to an expansion device, usually a valve, and this valve will essentially bring the pressure down, and liquid passes through back to the evaporator to be used again in the system. So the heat's being moved from the evaporator right around to the condenser, and being rejected there, making the space where the evaporator is cooler. So that's the very, very basics. We're now going to look at some typical refrigeration systems and give you some idea of what they look like, so you can identify them in your own business. So on the low pressure side of things, these are the evaporators. So this is the area where the thermal energy will be collected from the local environment, and the refrigerant is evaporated. So to cool air, you'll usually see walk-in cold rooms and display cabinets cooling air, and in terms of cooling liquid, you'll normally see plate heat exchangers. In terms of the high pressure environment, this is where you'll see the condensers. So these all deposit heat to a local environment, and this is, as I say, often externally. So when air is cooled, the most common method is by simply blowing air, so air-cooled condensers, but you can also have the water-cooled type as well. Evaporative condensers are often for larger systems and use the evaporation of water to aid the cooling process. Moving on to other key refrigerant elements, so the compressors. So this is where a lot of the heavy lifting is done, a lot of the main work. And you can see different types of compressors here. So you can see scroll compressors, reciprocating compressors, and the screw type as well. It's often prudent to use multiples of condensers in your refrigeration system to improve the part load operation. So a compressor will be more efficient when it's working at full load. So having multiple smaller compressors working at full load is more efficient than having a larger compressor working at part load. And on the right hand side there, you can see the expansion devices. So these are the valves that will use very little, if any, energy. So you won't see necessarily a big opportunity for energy savings there. Next up, you've got the chillers. So these are used in both industrial and commercial situations to produce chilled water or chill other liquids or fluids. So packaged chillers are factory assembled. They're self-contained units which include the compressor, the controls, and the evaporator. They also might include a condenser as well, but this can be a remote addition to the unit. Typically, these chillers are chosen to meet a maximum cooling load during the very warmest of weather. However, for most of the time, so 99% of the time, the chiller probably won't be running at these conditions. So the load will probably be smaller or the weather cooler, and this presents opportunities for energy saving, which we'll hopefully get onto a little bit later. So that's a look at refrigeration in its very kind of basic form. We'll now go into kind of some detailed ways in which you can identify energy saving opportunities within your own business. So there's a lot of content to probably cover here, so I'll go through it as efficiently as I can, but there will be opportunity for you to ask questions at the end if everything goes a bit too quick. So energy saving opportunities, you can have low cost and investment opportunities here. So you don't always need to invest your capital expenditure to make the necessary savings, but there are some clearly significant savings that can be made if you're willing to invest. On the right hand side there are the kind of the areas, the energy saving areas that we're going to cover today. So we'll go through each of these one by one and talk about the ways in which you can save energy with each. So we'll start with the display cabinet. So in terms of housekeeping, it's really important to make sure your cabinet isn't overstocked and make sure that the air grills are clear of product and merchandising. A properly stocked cabinet will maintain optimum food temperature with minimum energy consumption. That's what you're aiming for. It's also important to make sure the product loaded into your cabinets hasn't warmed up by being left in an ambient temperature area. When the shop is closed, use any night blinds and covers and switch off lights and anti-condensation heaters as well. If you have got lights under shelves, consider whether these can be switched off or maybe even removed. They might not be necessary. And do check the defrost settings of your cabinets and make sure that these are set appropriately to match the conditions of the environment and to avoid any unnecessary heating where possible. In terms of maintaining your display cabinets and some good low-cost measures of energy saving, it's good to have a frequent and useful cleaning schedule. So this will maintain the top efficiency of the product and a good overall temperature control. It's important to make sure that night blinds are well fitted and covers on all cabinets are available to reduce the load during non-trading hours. Think about fitting anti-mist film or spray and switching off the heaters permanently at times when it's not needed. Ensure all the expansion valves where you've got them are properly commissioned, and if possible use the electronic type. So these will be the most efficient type that you can use. In terms of investing in your display cabinets, in terms of lighting, make sure you use the most efficient lighting, which would be this time LED lighting in the canopy. If possible, consider fitting transparent doors to open cabinets. So this allows customers to still be able to view the product inside, but make sure that the cabinet itself is working much more efficiently. It doesn't have to work as hard to keep everything as chilled. If you're keeping your cabinets for at least 5 years, and you know you'll be doing so, look at replacing all of the lights and fans with low power alternatives. You can see on the graph on the right hand side here that the most energy savings typically can be seen in this area where you are able to select the most appropriate cabinet at the beginning of the process, like a brand new cabinet. But if you're in a position where you'll be retrofitting, making sure that you have that good maintenance and cleaning and efficient use of doors is probably the biggest things you can do in terms of retrofitting and receiving energy savings. In terms of your cold rooms, again, housekeeping, it's good to make sure you have good door management. So this essentially means that you're keeping the door of the cold store closed wherever possible. And this keeps warm air and, importantly, moisture out and bringing down your energy costs. Making sure that the airflow from the evaporators isn't obstructed, and run the cold store at the highest possible temperature for the product that you're storing. Ensure the product load in your cold room hasn't warmed up by being left in an ambient temperature area. Again, this is the same as with the display cabinets. And again, making sure that lighting isn't being used where it's not necessary. In terms of maintenance and low-cost measures that you could implement, repairing damaged door seals to making sure there's no transfer of air between the rooms, that is really important. Automatic and rapid closing doors are probably the best practice for this type of space. Strip curtains, really useful if they're well maintained at keeping the water air in and the moisture out. And make sure that the outside of the cold store is sealed airtight with no gaps in any panels or joints, and the insulation is covered throughout. In terms of investment measures, again, automatic rapid closing doors are the thing to invest in, as well as a defrost on-demand system, which we have a case study for a little bit later on in the content. For larger spaces, forklift accessible cold stores are an example. Incorporate an airlock or anti-chamber with dehumidification into the forklift entrances, and this basically reduces ice buildup and the need for any defrosting that you could potentially avoid. When purchasing new equipment, keep in mind that sliding doors are probably the best doors to use with a better seal, and they're also less likely to get damaged. Compressors. So again, this is where all the heavy work is done in your refrigeration system. So you can make really big impacts here if you make it easier for the compressor to do its job. So this is the part of the system that is working to raise pressure and therefore the temperature above the ambient temperature in order for heat to be rejected. So get your technician to set the condensing temperature to the lowest practical level. And once that limit is reached, it may be possible to upgrade the control valves that you have or condensing capacity to allow further reductions. Where you have multi-compressor systems, make sure the compressor suction pressure is set only as low as is required. So often the winter set point can be higher than in summer. In terms of investing in compressor systems, if you can't reduce the condensing temperature, liquid pressure amplification can be used, and so you can see savings of typically around 25% in this area, with paybacks of around 3 to 5 years. Where you have a varied cooling load across a wide range, consider using speed controllers for one or more of your compressors. So condensers are the next on the list. So this is where you need to make it really easy for the condenser to reject the heat. So find out where your condensers are and make sure that they're not dirty or blocked. If they are, they're costing you money. So make sure you keep the condenser, as they're usually external, clear of leaves, litter, vegetation, that kind of thing. So it's really important to inspect that. In terms of maintenance and your low-cost measures, ensure that the condenser gets cleaned by a competent technician regularly, and make sure that during the process of cleaning that dirt isn't just pushed further into the fans, the fins that are used in the system. Check that the fans are all working. Remember that some may be switched off at times by the pressure controls, but just investigating whether they're all working gives you a good indication whether the system is working efficiently. If you're looking to invest in your condenser system, then it's likely to be accumulating dirt, so consider fitting a removable condenser screen. So this is essentially something that can just be hosed down or replaced when it gets dirty, and stops the condenser accumulating that dirt. And if your condenser is struggling at peak times, consider fitting an extra one to take the load off, essentially, that condenser. When you're purchasing or designing a new system, look at getting a larger condenser than you normally would. Integrating a separate subcooling section will offer further savings of at least 8%. So having a larger condenser there than you normally would can give you some savings. And the newest condensers obviously have low energy fans and EC motors. So this will offer you significant power savings and the ability to control the system a lot better. So evaporators. So this is where heat's collected. So again, make it really easy for that heat to be collected. Keep an eye on them. Make sure that if you see any permanent buildup of ice, that you investigate that. That's a good indication that something's gone wrong. Where there are evaporators in rooms such as production areas, you can switch these off when the rooms aren't being used. Evaporator controller is usually the room thermostat, so make sure that this is set as high as possible without compromising obviously the product you're trying to keep chilled. And in terms of maintenance, again, making sure that the evaporator is cleaned when it's dirty. So the more dirty it is, the worse the performance of the system. So making sure that your technician is regularly cleaning and checking that the system is working. Again, checking fans are working and checking that drains are fitted with traps to prevent air being drawn in from outside. Again, insulation is also really important and useful in an evaporator. Moving on to heat recovery. So heat recovery is a really useful way of making use of the latent heat that is dumped by a refrigeration system. So in a system, thermal energy that's collected from one space and delivered to another is essentially dumped externally and not used again, but you can actually recover heat from the system. So there are two types, high grade and low grade heat. You can see that the high grade heat that you can recover is at around 50 or 60 degrees Celsius, and that the low grade heat is around 20 to 30 degrees. So you can use both of these types of heat. The high grade can be used for a small amount of kind of domestic hot water for washing and cleaning. And the low grade heat can be used for preheating boiler feed water. So in factories where you might have a lot of hot water requirement, potentially for cleaning at the end of a production shift, boilers are often heated from between 7 to 80 degrees in winter, and the heat recovery system can actually preheat this water in advance, so to around 20 degrees. So that basically reduces the load of the boilers by about 18% during those winter months. So you can see considerable savings by using heat that was essentially lost, and it's essentially a free gain for you to be able to use. Low grade heat can also be used in underfloor heating in cold stores and dry goods stores, and some systems can use a heat pump to raise the temperature of recovered low grade heat to exactly what's required by a factory. So there's lots of uses of heat that can be recovered, especially from a refrigeration system. But do bear in mind that when implementing a system like this, it's recommended that you do use an experienced contractor who is familiar with specifically heat recovery. It may be something that the Green Business Fund can support you in with our free audits and advice, but we'll get onto that a little bit later. The potential savings that can be gathered from heat recovery are a really attractive investment. So the payback on a system is probably about, a typical system is probably about 3 to 5 years. So this length of time is based on the high capital cost initially of extra heat exchangers, pipework and controls, but the savings overall are really quite significant. So the heat recovered is essentially free, and it's a really attractive investment for anyone who uses a significant amount of refrigeration. Reducing leaks. So reducing leaks is really important. It's actually part of the obligations regulation that you as an operator of a refrigeration system must adhere to, as well as your kind of maintenance, your service provider. So when you consider that in the UK there's an average leakage rate on refrigeration systems of about 20%, this means that overall in a typical system you'll see an 11% reduction in its efficiency. So while it's a regulation and you do need to keep track of the leaks and maintenance going on with refrigeration, it's actually a benefit to your business to make sure that you keep on top of these checks, and you can really see energy efficiency gains from doing so. So have a look at this chart and make sure that the size of your system is getting the frequency of checks that it needs. And if you're under any doubt, then there's lots of information on the .gov website about regulation for refrigeration. So the next part of the energy saving opportunities section is free cooling. So this is essentially an area where if the external ambient temperature conditions are cold enough, which in the UK they tend to be, then you might not need to work compressors at all. So the case study on the right hand side here shows that there was a manufacturer who we spoke through the Green Business Fund who had a requirement for chilled water. They were able to install a free cooler that would produce 16-degree water for 200 days a year, only using fans, so not using the compressor at all. So this made use of the external ambient temperature, which was cool enough. By installing this, they were able to save around £19,500 a year, and that project, although costing £45,000, paid back to them in simple terms in 2.5 years. So again, a really attractive investment if you've got the capacity and the requirement there to use it. So chiller systems. So these are the package systems that I mentioned a little bit earlier on. in the session, which contain the evaporator, the compressors, the expansion valves, and the condensers all in one. So they're often selected for the requirement of the full load of the chiller. So this might be correct depending on your requirements, but it's likely that 99% of the time, given the variability of load and the UK's relatively cool environment, that the chiller is likely to be running at part load. So 97% of the time it will be running it at part load. So it's vital that when investing in a new chiller, a new package system, that you ensure that the chiller is engineered to maximize the efficiency at part load. So you can see that in summer, between chiller A and chiller B in this example, you don't really notice much difference in efficiency. But during the winter months, chiller A, which has been engineered to be more efficient at part load, is the more efficient chiller to have. So making sure that you have the right one right from the off, and that it works at part load is really, really beneficial. Pipework installation. So this is something that in the short term you might not notice costing you much money, but over the long term it really will add up. So most systems will have this kind of pipework, and if it's not insulated properly, you can see extra heat gains that potentially cost you an extra 15% or potentially even 25% of the capacity of the refrigeration system if you don't insulate properly. So make sure that you're generous right at the beginning with good thickness and the insulation being sort of delivered overall across your system, across all pipework, and that it's built to last for the lifetime of that equipment. If you've got the ability to use thermal imaging, or your service provider does, this can really indicate to you where you might be having extra heat gains that you don't really want in your pipe system. Overall maintenance. So you can consider this list on the slide essentially a checklist of what the minimum should be for your maintenance provider in terms of your refrigeration system. So don't let them get away with anything less than this. If any or all of these things aren't being checked regularly, then you need to ask the question why. And again, although it's something that should be done for all manner of reasons, you can definitely see energy savings from implementing all or most of these checks overall. So they are a benefit to your business, and they are really useful to be doing. In terms of monitoring, it's good to keep tabs on both the pressure and temperature going on in a system. So the temperatures will give you a really good indication as to whether a system is working as it should be. So it can give you an indication about whether there's any refrigeration leaks that need to be looked into as soon as possible. And in terms of temperature, you can clearly see where you can make sort of granular changes. So if you've got granular data that tells you that different cabinets and their temperatures, you can see that different cabinets may need different kind of changes made to them. So an example we've had and that we've worked with was a small supermarket that had a clear display of temperature on all of their cabinet units. So they're able to see which ones were defrosting when they shouldn't be, and they were able to make individual improvements to each of those cabinets. So making sure you have the granularity of information available to you can be of real benefit. So that was a real whistle-stop tour of all the typical energy saving opportunities that can be found within refrigeration. Feel free to listen back at any time. I understand that was a quick run through. And again, if you've got any questions about any of those, then do let us know, and we can look to answer them. I'm now going to sort of briefly talk about the other considerations that you need to bear in mind when you're looking at refrigeration and when you're operating a refrigeration system. And this is mostly to do with regulation and legislation that has been and will be coming into play in the UK. So in 2018, the quantity of HFCs, or hydrofluorocarbons, which are essentially used as a refrigerant gas, a refrigerant in your refrigeration systems, most commonly, are essentially to be reduced. So the availability of these on the EU market and in the UK generally would be reduced in this time. So there's a general goal by the government to reduce the prevalence of HFCs in the UK by 79% between a baseline of 2015 to 2030. So the first big cut happened in 2018. That was about 40% of the HFCs on the market were sort of cut out. So you can see on the slide here that that there are a global warming potential attributed to different refrigerant gases, and the idea is to phase out those refrigerant gases that have a high global warming potential. So this is always an equivalent to CO2. So you can see here by 2030 or 2035, the number of HFCs in the EU market will be much lower. So it's important to understand what kind of HFCs you have in your system, if you have them at all, and take action. So the next thing to consider is that in 2020, the next big change will be coming into effect on the 1st of January of that year. So that essentially means that refrigerants with a global warming potential greater than 2,500 that are used to service or refill your existing refrigeration systems will be banned. So the ban affects systems containing hydrofluorocarbons equivalent to 40 tons of CO2. So I'll give you an idea about what that means, what that relates to in terms of the mass, the amount of refrigerant you may have in just a second. But the headlines are essentially that if you fail to comply with the regulation, then you could see penalties up to £200,000. So it's really important to make sure that you're fully aware of all the regulation and legislation going on with refrigerants. So a couple of commonly used refrigerants that you might be aware of, that you might see commonly being used on your site, are R404A and R407A. So they're subject to the ban, and there will be others, but they're just two of the most common ones. So what action should you be taking as an operator? So it's important to firstly understand the CO2 equivalent of your existing refrigerants, so the global warming potential. Your manufacturer or technician may be able to tell you that, but you also can find out yourself. So CO2 equivalent is a measure of how much gas contributes to global warming relative to carbon dioxide. So each refrigerant is given a global warming potential, and this is multiplied by the mass of the gas used, usually in tons, and the service provider that you have or the technician that you have can offer advice based on that, on what steps to take next. So those steps could include using reclaimed HFC refrigerants. So these are exempt from the ban until 2030. You could use recycled HFC refrigerants. So these can be recycled by yourself as the operator or by the company that is servicing your equipment. So again, these are exempt from the 2030 ban. Or you could switch to refrigerants with a low global warming potential altogether, and these won't be covered by the service ban. So you can find out which are the lowest global warming potential refrigerants and use those instead. If you decide to move to these low global warming potential refrigerants, it will probably involve replacing or retrofitting your existing system. So less of your equipment will actually be affected by the ban if you buy equipment that uses refrigerants that use these low global warming potential refrigerants. But obviously there will be a cost associated with that. As discussed in these slides, the regulation on F-gases and refrigeration looks to continue into the immediate and long-term future. So ensuring that you have the most efficient equipment and an up-to-date understanding of the rules can help you future-proof your business against these changes and any future changes that come. So making sure you have the most efficient equipment means that the ban will be less likely to impact you as quickly. So the regulation can be confusing. So we advise making sure that you look at that guidance that's available on the .gov website for the most up-to-date and detailed information. They do update that when any changes do come into effect. But just to give you a general idea about the kinds of F-gases that might be affected and the the mass needed to trigger a service ban. These are some examples. It's obviously not the full extensive list, but some common ones that do come up, and the mass associated with them to trigger that 40 tons of CO2 equivalent. So we're going to look over a couple of case studies for energy saving opportunities, and so these will essentially cover some of the things we've talked about, but give it in some kind of business context. So a supermarket chain that we worked extensively with had a range of smaller and medium-sized convenience shops, they might be described as, and so the information on the slide here is essentially a breakdown of those smaller and medium-sized shops and what the supermarket chain was able to achieve in terms of energy savings with those sites. So you can see that in terms of the old sites that didn't have many initiatives inputted into them, they sort of maintained a kilowatt hours per meter squared of site of around 1,175 kilowatt hours, where they were able to build a brand new installation. This of course had the most impact on energy savings. They were able to implement everything, all the most up-to-date equipment and best practice available, and they're able to bring that that energy use right down. Where they weren't able to do that, and where they had existing sites that couldn't be knocked down and rebuilt, and they weren't building new sites everywhere, they were able to retrofit. And even just by retrofitting and introducing a good cleaning schedule, things like night blinds, but specifically the doors to chill cabinets, probably the most effective, they were able to bring their existing energy use right down. So this just gives you an indication of things that can be achieved by retrofitting. A kind of a small business example. So there was a butchers that we were in conversation with as part of the Green Business Fund, and we offered advice to, and they were on the south coast, and they had persistent issues with buildup of ice on their evaporators. So what they were able to do was install a defrost on demand system, which we mentioned earlier, which is basically an automated system which was able to save them £2,500 per year. So with an initial outlay of £9,000, they were able to pay back the cost of that project in just over 3.5 years. So so some considerable savings paid back pretty quickly there. In terms of heat recovery, this is a really good example of a manufacturer, and specifically a ready meals manufacturer, who obviously has a lot of demand for refrigeration in their line of work. They had a hot water requirement on their site, which was at the time being met by a hot water tank. But because of the size of the chiller unit they had for their line of work, we were able to identify and recommend to them that up to 30% of that heat that was originally rejected by the system could actually be recovered. And it could be used to meet the demand for hot water on site. So we made some assumptions about the recovery rate and the utilization factor of the heat recovery system, and were able to model for them that they would be saving around nearly £65,000 a year just by introducing heat recovery to their site. So this is quite a large scale example, but there may be some small or medium-sized businesses who predominantly use refrigeration in their business as most of their energy use, and so where that happens, you can see some really considerable savings by introducing heat recovery. Basically, the sites that use refrigeration systems that chill down to the lowest of temperatures, so deep freeze units and considerably sized ones, will see the most useful high temperature heat recovered from a heat recovery system. So where you chill down to the lowest levels, that's where you can see some really useful heat that would otherwise be wasted. So I'm going to briefly touch on the Green Business Fund and the services that are going to be available to small and medium-sized businesses in England, Scotland and Wales. So it's a scheme that the Carbon Trust operates and is designed to help small and medium-sized businesses, schools, sole traders and charities to become more energy efficient. The criteria for a small and medium-sized business is the UK government criteria, which is on the right-hand side there. And if you meet 2 of the 3 bullet-pointed criteria there, then you will be eligible for the services that we provide. There is one service that we can provide to large companies, and I'll mention that when we get to it. So the first thing that we do is we offer workshops around the country. So today's webinar was a very specific technical overview of refrigeration, but in our sort of 2-hour sessions that we run around the country, we cover as much as we possibly can in the time frame on energy efficiency overall in a typical business. So we'll talk about energy management and all the other technology groups that you might be able to think of, and you'll be given the opportunity to ask us any questions face to face, and hopefully we'll be able to answer those for you. So if you're interested in signing up to a workshop, do visit the website and see if there are any nearby to you anytime soon. The most popular services that we do offer are our energy assessments. So these are essentially fully funded, no cost to your business audits by our experts. So it is independent, unbiased expert advice on where you can find the best energy savings in your business. So it is bespoke and specific to you. So we'll give you the top 3 costed energy saving recommendations as part of a report, and be able to provide lots of advice to you on how to implement those. If you already had an energy audit of some kind, or you've had one of ours, or you just know what you want to do in terms of energy efficiency investment, then we can offer you implementation advice. So this is where we'll give you up to 5 days free support from one of the consultants who will be able to go out to tender with suppliers, help you put together tender documents, and really help you feel confident that the project that you're trying to implement is right for you. This is the advice that we can actually offer to some larger businesses. So companies up to 1,000 employees can receive this service. So if you're interested in either of these, then again, please do let us know. So as you'll be fully aware, we do offer technical webinars. So just to let you know that there are a lot more available to you. So we've got more coming up throughout the rest of the year. And all the previous webinars that we have hosted are available online for you to look at your leisure. And then similarly, we do have publications. So both the technical webinars and the publications cover all manner of commercial sectors, industry sectors, as well as technology groups. So if you're interested in any specific advice that you want to sort of look through at your own pace, then feel free to download any of those. We do have energy saving tools that we've developed for 2019. So the first one, again, free to use, available online, is our carbon footprinting tool. So this helps businesses measure their emissions footprint following the Greenhouse Gas Protocol guidance. So a really useful first step in understanding where you sit in your sector and in your industry. Benchmarking your energy use specifically compares you against other people in your sector and industry, so you can see how you measure up, if you've got work to do, or if you're potentially best in practice. And then finally, we can help you build your specific business case for a lighting upgrade. So all 3 of these tools will require a few bits of information about your energy use and fuel use, and we'll be able to provide you results pretty quickly on each of these things. So if you're interested in using any of these tools, again, they're available on the website via the Green Business Fund page. We do have an accreditation for suppliers. So those of you looking at acquiring quotes for certain kinds of projects can use our Green Business Directory to find accredited suppliers who we've accredited for their delivery of high quality energy efficient solutions. You can find these on the website. You can use the tool there available, which is a map tool. You can sort by technology and you can find those suppliers yourself. We can shortlist suppliers on your behalf if you're just after a couple of suppliers to contact for your project. You can ask us and we'll give you the details of any suppliers that you might need. And if you are a supplier yourself and you want to become accredited, then that's something we can also discuss if you deliver a energy efficient technology to market. So we do have an energy efficiency loan fund. So this is available only to applicants from Wales, so only available if you're based in Wales. And so the loan will cover energy efficiency equipment and renewable technology investment for your business in Wales. And the loan will be between £3,000 to £200,000 and will be based on the tons of CO2 saved. So for every ton of CO2 saved, we'll look to provide £1,000 in form of a repayable loan. There are some slightly different criteria to the Green Business Fund criteria for the loan scheme. So it uses this slightly different definition for an SME, which is, I believe, the European definition. And there are some additional criteria involving state aid that you do need to be aware of. Brief overlook of the types of projects that we'd look to provide funding for from the loan scheme. We'll look at providing funding for projects that replace essentially an on-site fossil fuel need and renewable energy projects as well. Do bear in mind that we won't be looking to provide a loan for new builds or relocations. Here's a brief example of some of the technologies that we have funded through the loan scheme. So if you're interested in installing any of these, obviously including refrigeration, then do get in contact if you're based in Wales, and we may be able to provide some funding for you. To make sure that you're getting the most efficient technology, you can use the energy technology list. So this is a list that we manage on behalf of government, and is basically a collection of all the most efficient products within their individual categories. So refrigeration is there specifically. So if you're looking to find the most efficient refrigeration system, you can utilize the list to make sure that you're getting the best in the market. For a limited time, there is an enhanced capital allowance available with purchase of equipment from the energy technology list. And there's more information on this slide and the next slide about how to make the most of that and where to start, depending on whether you're a manufacturer, a purchaser, or anyone else in particular at all. So that's the energy technology list. I'm now going to open the floor up to questions. So I'll mute the microphone for a moment or so just to look through the questions, and then I'll be back in just a minute to answer any that have come through. So do bear with me. Okay, so giving you some time there to input any questions. So the first question that I've got here was how do you listen back to the webinar? So we will publish a link to the webinar on our YouTube channel, so you'll be able to watch it on YouTube whenever you like. So, and that's where all the other webinars that we produce and any future ones that we produce will be listed as well, so you can look through any or all of those at your leisure. The other question that I have is someone's asked what's the difference between recycled and reclaimed HFCs. So basically F-gases can be sent to a specialist plant where they can be therefore reclaimed and then resold. So that's used F-gases sent to a specialist plant and that's reclaimed. but it's also possible to recycle gases at your own premises when a system's decommissioned. So this is done by your technicians, and so that can be used by either yourselves or, again, the technicians who've used that product. So I think that may be all the time we have. But if anyone wants to get in touch about any of the services we offer or have any questions about the Green Business Fund at all, then we are happy to talk further about any of that. So thank you very much for attending, and goodbye.